Excellent. Hi, everybody. It's great to have you with us. I'm so glad that you guys remembered that we switched the class to a Monday and we're not meeting on a Tuesday anymore. See, now I've got all my hellos in the chat. Hi, everybody. Let's try the 2 questions that are on the screen at the moment. Give them a try, guys. Remember, we were talking on last week, Thursday, we were talking about when we have 2 fractions that are being added or subtracted, we need to find the something. Who can remind us what is that something that we need to find? Don't forget the what. Tell me in the chat, guys. What do we need to remember? That's it. Thank you, Akwando and Q. Hello, Karabo. LCD. We need to find the LCD. Hi, Londile. Excellent. Well done, Ntokozo. Karabo says they can't hear me. Can you help them out, please? I think Onwabo is having the same problem. Okay. Thank you, Janaliswa. That's it, guys. We're looking for the LCD. Hi, Esther. If anybody's feeling generous, do they think they want to pop the LCD in the chat for us? What's the LCD, guys? Hello, Awande. Thank you, Nico. So nice of you. So nice of you to pop the LCD in the chat. All right. I think many people can't hear us. Just give it a second. Look for the headphones icon and connect to audio. That's it, Michael. That's exactly what it is that we're looking for. Okay. All right. Guys, we're going to get started on this question. I'm a little worried that we might lose time. So I want to make sure that we remember we get in as much as we possibly can. Now, if my LCD is 6, I'm going to draw a line like this. What did I do to 3, guys? What did I multiply 3 by to get it to 6? Tell me in the chat. That's it, Deborah. Well done. I multiplied by 2. And what I do in the bottom, I'm going to do at the top. So I'm going to get 2 times 2x, which is going to give me 4x, plus, what did I do to this LCD? What did I multiply it with to get 6, guys? By 3. Sorry, I'm sipping water. By 3. And what I do to the bottom, I'm going to do at the top. 4 times 3x is going to give me 12x. Okay. And this is going to give me 16x. I'm just going to add the things on the top. 16x over 6. Right. I can simplify this even further because of my numbers. What number goes into both 16 and into 6, guys? It can't be 3. It cannot be 3. That's it. Let me see who said that first. Sadula. I hope I said that correctly. Sadula. Well done. Okay. 2 goes into both these numbers. So I'm going to divide by 2 here. And I'm going to divide by 2 there. And that's going to give me 8x over 3. Well done for picking that up. Okay. Let's try number 2, everyone. Oh, it's Mirula. Oh, hi. Hi, Mirula. I'm wondering, I'm like, Sadula, it sounds very familiar. I'm just not seeing it. Okay, excellent. Hi, Mirula. Nice to have you with us. All right, give me an LCD down here, guys. What is my LCD over here at the bottom? LCD, that's it. Akwando. That's it. It's 20. And take it from there, guys. Now, I'm going to remind you again, guys, pro tip. This negative belongs to whatever is happening over here. Okay. I'm going to give everybody about 2 or 3 minutes to get it done. Titan is Inganati. Hello, Titan. Oh, Inganati. Excuse me, guys. Sure, today's been such a long day. If you've got an answer, you can pop an emoji in the chat, or you can pop the answer in the chat if you're feeling nice. Mbali, it's because we can simplify the fraction. Mbali, if I have the fraction 16 over 6, that's not, the fraction isn't in its simplest form. So I still have to make it, I need to simplify the fraction as much as possible. Akwande. Amy says, what are we doing? Amy, we are simplifying. Okay. That's what we're doing. Okay, we've got an answer. We've got one answer in the chat. Let's see if everybody else agrees with you. Yeah, Mirula, that 50. Why is your answer over 50? That's very suspicious. Something seems a little off. X minus 13 divided by, it's a typo. I see. I knew it. All right, let's get started. All right, so we know that our LCD is 20. We're going to do that. Yeah. And I know to get from 4 to 20, I need to multiply by 5. And what I do at the bottom, I need to do at the top. Now that whole thing is multiplied by 5. And I think some Kelwe fell for my trap. We're going to see, I'm going to show you what that trap is in just a second. What did I do to 5 to get it to 20? I multiplied by 4, and then I have to multiply by 4 at the top as well. But remember, Samkele, that this negative goes to 4. So what I'm going to be multiplying in over here is negative 4 and not positive 4. Okay, so I'm going to end up with 5 multiplied by x minus 1 minus 4 multiplied by x plus 2. Okay, I'm just going to make this shorter. I feel like it's way too long. All right, yeah, let's do that. There we go. And then I'm going to distribute in. Distribute, 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 distribute. So what I'm going to get is 5x minus 5 minus 4x minus 8 all over 20. And then now I need to move to the side because I'm running out of space. There we go. All right, is equal to, and then I'm going to add like terms. 5x minus 4x will leave us with x, and negative 5 minus 8 will leave us with negative 13, all over 20. And you guys are absolute rock stars. Well done. Amazing. Braden's like, sorry, ma'am, I'm late. Did I miss anything important? Yes, you did, Braden. How could you come late? I cannot believe you. No, I'm just kidding. You didn't miss anything important because you were with us on Thursday and we were just doing a quick recap of everything we did on Thursday. We were just doing a recap of everything we did on Thursday. Okay. Hello, Mivuyo. Well done, guys. All right. Nsako says, ma'am, don't we add like terms? We did, Nsako, we did. We did. I did this. I went 5x minus 4x, and that gave us x. And then I did the numbers. I've got negative 5 minus 8, and that gave me negative 13. Okay. I hope that makes sense, Nsako. I did. I added all the like terms together. 7 of 8. All right. We're still looking at adding and subtracting fractions, but now we're going to complicate the LCD a little bit more. All right. Muriel, they're all on the website. Okay, Teacher Annalisa, can you drop a link for them in the chat for me? Thank you so much. All right, let's have a look at these two. We're subtracting over here. So I'm going to have to find an LCD. Tell me in the chat, guys, what is my LCD? What is my LCD? That's it, Q. Excellent. My LCD is 10. All right, so I already know that this whole thing is going to be over 10. This whole thing, yeah, over 10. I think I'm making these things a little too long. Maybe let's make it a little bit shorter. I'm being extra. I'm being super extra. Let's write this. Okay, good. So now we need to figure out, what did I do to 5? to make it 10? I multiplied by 2. What did I do to 2 to make it 10? I multiplied by 5. All right. Mulisa, I see your hand is already up, my sweetie. What I want you to do is, I want you to try this question for me first. I want you to go and write out the answer and then leave your hand up. Don't put your hand down. Once you found the answer for me, you and I are going to have a conversation about it. Okay, quickly, on your Watobe notebook or your scribble paper there, work out the answer. Okay, and then we're going to have a conversation. I'm going to give everybody 2 minutes to finish this question. Go for it, guys. That's okay, Nonkululeko. You can do that. Excellent. We're right here. You can come straight into the classroom when you're done. Ayanda says we haven't got to factorizing fractions yet. Ayanda, like I was saying, we are way ahead. Okay, so if you watch our previous lessons, you're going to bump into things that your teachers are only doing now, but we've already done. Okay, so you can watch the lessons that we've already had, have a look at them, like Teacher Neliso just dropped all the links to them in the chat, and you can have a look at everything that we've done. We're like ahead. We are very, very much ahead. Somebody named User just gave us an answer in the chat. Okay. Good evening, Denzel. It's nice to see you again. Somebody named User. User, we need your name. Okay. We need your name, please, User, so we can change it for you. Smagele, do you have a question for me, my sweetie? Ah, thank you. Kayla, we can change your name for you now. Hello, Smagele.
Hello, ma'am. I actually wanted to ask, yeah. So as you said, we're gonna have to multiply the denominators. For example, you had 5 and 2. So we're gonna say 5 times 2, which gives us the 10, and then 2 times 5, which gives us the 10. That means that our denominators are gonna be 10 for both fractions. Yes. And then moving up, we're gonna have to multiply 2 times x, which will give us 2x, and then 2 times -1, which will give us -2. And then we'll have to move to the next fraction, and we'll have to times 5 times x, which will be 5x, and then 5 times 3, which will be +15. Is that how you do it?
Yes, but Smangele, you've missed something. Remember, there's a negative in between here, hey? So when we take this 5 into the bracket, it's no longer 5, it's -5. Okay, don't miss that. That's very important. So when we multiply that 5 in, it's not 5, it's -5 times x and -5 times +3. Okay, don't fall for that trap. Okay, excellent. But everything else you explained, 100% on point. Well done.
Okay, thank you.
All right, excellent. Onwabo, yes, that is very possible. Okay. Onwaba, actually, I think I'm pronouncing it wrong. And I've lost Mulisa. I don't know how I've lost Mulisa. Michael, would you like to help me with this question? I mean, Smangele already gave us the answer, but let's see where this question is going. All right. What's it going to look like, my dude?
Ma'am, so you read, okay, so ma'am, so the LCD is 10, right? So now we'll say now 2 times x, which gives us 2x. Then you say 2 times -1, which gives us -2.
And then we'll have.
And then after that, we go to the other section. Then you say -5 times x, which will give us -5x. Then we'll say -5 times +3, which will give us -15.
Well, yeah. All right. We're not quite done. Don't go away, Michael. What happens to the top? What do we need to do on the top?
On the top, ma'am, we need to add the like terms together, ma'am.
That's it. Excellent. What are my like terms?
The like terms is 2x minus 5x.
And how much is that? 2x minus 5x is?
3x, ma'am.
Oh, not 3x. 2x minus 5x will give us?
Oh,
2 minus 5.
Minus 7x, ma'am.
not -7. Remember, if I've got my number line and I'm at 2 and I move 5 spaces backwards, 1, 2, 3, 4, 5, I'm going to end up at 1, 0, -1, -2, -3. Where did I end up? -3. That's it. So it's going to give me -3x. And then what about my numbers? -2 -15. How much is that going to give me? -2 -15 will give me?
It will give us, let me just group check here. It will be giving us -17, ma'am.
-17. Very well done. That's the answer I was looking for. Very well done, Michael.
Thank you, ma'am.
Okay, excellent. Let me just have a look at my chat quickly. Matatsi, because you're multiplying +2 and +x, which is equal to 2x. That's it. Thank you. Thank you, teacher Neliswa. Ma'am, if you put the part where you collect like terms separate, like you make a whole new sum with it, then you get your answer. Is it correct? Yes, Braden, it is. Because this thing could easily be written, we can rewrite this as -3x over 10 minus 17 over 10. And it's still correct. Okay, it's still correct. It's the correct answer. All right, we still have the same answer. No problem, Melissa. I know it does get quite tricky sometimes. I hope that answers your question. Okay, I'm just checking to make sure. Okay, thanks, teacher Nelson, for explaining that. The reason why the 2 doesn't become -2 is because we only have a 2 in the next part. Q, we do not need to write the second step. I think Braden is just being a bit pedantic, but that's fine. Karabo, that's perfectly fine. If you're having load shedding issues, guys, we do record these lessons, so you guys will be able to see those. Okay, you'll be able to get to them much later on. I can actually delete this. Okay, I'm going to move this down a little bit. All right, let's have a look at this question over here, guys. Let's have a look at number 4. Okay, what is my LCD going to be over here for number 4? I've got X and Y as my bottom. What is my LCD going to be? Okay, I thought this was going to be difficult for everybody, but you know, my LCD, it's easy for you guys. X, Y. Okay, let's talk about why this is. If I asked you guys, if I had 1/2 plus 1/3, what would my LCD be? What would my LCD be? Mulisa, tell me, what's my LCD over here? I know specifically, that's what I'm trying to explain. What's my LCD, Mulisa?
It will be 6.
I see you. It will be 6. Good. How did you get to 6, Melissa?
2 times 3.
Good. We took 2 and we multiplied it with 3. 2 times 3 gave us 6. So when we find the LCD, we're always going to take the 2 numbers at the bottom and we're going to multiply them together, right? So if I want to find the LCD of X and Y, how am I going to find the LCD? I'm going to
Put them together.
I'm going to multiply them together. Good. So X times Y is going to give me X,
Y.
Y. That's it. Don't go away, Mulisa. We're not done. We are not done. Okay. Let's continue. Specifically, I hope that makes sense to you. Why we actually say X, Y. It's because when we find the LCD, if you find the LCD, we actually multiply the 2 numbers in the denominator together. Felix, on the website, the same site that you used to get to today's lessons, okay, if you scroll down, you're going to be able to see all of them. If you're on the app, scroll down and you'll see all the lessons we've already done. Okay. All right, Melissa, how did I get from X to XY? What did I multiply X by to get it to XY? Multiplied by?
Y. X, you
Good,
multiply
by
them
Y.
together.
Exactly. So I need to multiply the top by Y as well.
Right.
And what did I do to Y to make it XY?
You multiplied it by X.
Good. And what I do at the bottom, I'm going to do
it
at the top. Excellent. All right. So my answer is going to be, what is 2 times Y?
2 times Y is 2Y.
Good. Plus 3 times X.
3X.
That's it. 3X. Can I add anything else? Is there anything else that I can do here?
No.
No, not at all. So you've given me the right answer. And that's why you're a whole rock star. Very well done, Melissa. Well done. Excellent. All right. Can I get a thumbs up, a thumbs down? Do we understand how we got to this answer? Give me a thumbs up, guys. If not, we can always try another one. Thanks, Mirula. I'm getting many thumbs up and I love it. Excellent stuff. Excellent, excellent, excellent. Thanks. Awesome stuff, guys. Awesome, awesome, awesome. All right. Kayla says, I'd gotten it wrong. Do you see where you've gone wrong, Kayla, or do you want us to try another one? Okay, let's do this. Can we move on? Okay, type in the chat for me, move on or another one. Which one do you want? Do you want us to move on or do you guys want another example? Okay, I'm getting a move on. I'm getting other people saying another one. Another move on, another example, another one. Okay, guys, I think the another ones have it. I think the another ones have it. Okay, let's try one more example. All right, we're going to call this one 4.0 or 4.1. All right, I'm going to say, guys, 3 over 2x plus 5 over y. Okay, what is my LCD? What is my LCD, guys? Have a look. If you feel like you want to move on, guys, please try number 5. Try number 5. Okay, if you want to move on, have a look at number 5. Go ahead and move on to number 5 before we do our brain break. That's it. I see you guys. My LCD is 2xy. Excellent. All I had to do was take 2x and y, multiply them together. Excellent. So I know that my LCD is going to be 2xy. Okay, and then I'm going to do that. What did I do? Guys, tell me, what did I multiply 2x by to get it to be 2xy? What did I multiply by? That's it, Mirula. So easy. I multiplied by y. And at the bottom, what I do at the bottom, I'm going to do to the top. What about on this side? What did I do to y to make it to 2xy? What did I multiply by? I multiplied by not just x tebogo, 2x, because there's a 2 in my denominator as well, 2x. And then I multiply the top by 2x. Okay, so now at the top, I've got y times 3, which is 3y, plus 5 times 2x, which is 10x. That's the answer, Kayla. Excellent, excellent stuff. Well done, Abigail. That's exactly what I was looking for. All right, you guys are killing it. Amazing. Api was like, ma'am, how come you always have electricity? It's a secret, guys. I know somebody at, no, I don't know anybody at ESCOM. I happened to live, I happen to live in an area where we have a very, very, very big inverter. It's like, it costs a couple of millions, and it's because I'm on the school grounds of a particular school, and we have a very, very big inverter that cost us many, many millions. And every time there's load shedding, our inverter kicks in and we never have load shedding. Braden doesn't have load shedding either. Why aren't you guys picking on here? We see, we never have load shedding. Me too, Braden. It's just not me. So guys, what can I say? Some of us, we just walk in the light, guys. Some of us, we just walk in the light. So I'm kidding. We do, Apiwe, we do. See, Inganati also has an inverter at home. Braden, now I feel like you guys have some shady dealings there by that PowerPoint at your house. All right, let's have a look at this next one. See, Makatse, wow, guys, the shade. Makatse is like, what's load shedding again? You guys are the worst. I can't believe you guys. Oh, yo. Okay, all right, guys, let's focus. Okay, let's stop bragging. I know we live really good lives. Let's stop bragging. Yes, Muriel, you can come live with me. Absolutely, come through. Come. I live in a village, though. So there's not much to do. It's fine. Okay, excellent. All right, guys, let's focus on number 5. We're digressing. All right, let's focus on number 5. Here's another question for you guys. If I said to you guys, I have 1 over 2 plus 3 over 4. What is my LCD? What is my LCD? You guys are saying 8, and I hear you guys, but Neo says 4, and Ayanda says 4, and Specicle says 4, and I agree with them. I agree with them. I agree with 4. Who can tell me why I agree with 4? Explain to me, guys. Those of you who say 4, why do you say 4? Okay, good. Mirula says 2 times 2. Tatum says because it's the lowest. Okay. Also, guys, do we all agree that 2 is contained within 4? Inside 4, one of the factors of 4, that's it, Makadze. One of the factors of 4 is 2. So 2 goes into 4, right? Yes, because if I look at how to make 4, I've got 1 times 4, and I also have 2 times 2. So I know that 2 is inside 4. So I don't have to write 4 times 2. I don't have to write it again. I already know that my LCD is going to be 4 because they're both factors of 4. That's it, Samkele. I could not have put it better. Samkele, that's it. Okay, we are doing number 5. We are doing number 5. And I'm getting to the point, Braden. Just watch where I'm going. All right. Now, if I had to break down x squared, I can rewrite x squared as x times x. Do you guys see that x is contained, this x is contained within x squared because x is inside x squared. X and x squared, the x is already inside x squared. Okay, it's already in there. So I don't have to repeat it again. I don't actually have to go x times x squared. I don't have to multiply them like this because this x squared already has x in it. So if I had to ask you guys now, what is the LCD? What is the LCD of x and x squared? Tell me in the chat. Oh, it's not going to just be x. Which one is the bigger number, guys? Between x and x squared, that's it, Mivuyo, that's it. X squared. It's always going to be the bigger number. Amy, if you say x cubed, you're going to complicate everybody's life. And then at the end, we're just going to have to take out a common factor again. Okay, it's x squared. This is the bigger number. X squared is the bigger number. Okay, that's fine. Even if you did say x cubed, those of you who said x cubed, I'm going to show you what's going to happen if we actually use x cubed as an LCD. Right, my LCD is now x squared. Now let's see what we're going to do with the sum. My LCD is x squared. Yeah, what did I do to x, guys? What did I do to x? What did I multiply x by to get it to be x squared? What did I multiply it by? That's it, Inganati. I multiplied it by x. And what I do at the bottom, I'm going to do at the top as well. Okay. Now on this side, what did I multiply x squared by to get it to be x squared? By? Yo, Inganati, you're on fire today. That's it. By 1. X squared times 1 is equal to x squared. So I'm going to multiply the top by 1, which is pointless. It's the same thing. It's the same thing. Now I've got x times 1 at the top, which is x, minus 4 times 1, which is 4. So my answer is actually x minus 4 over x squared. And Deborah, you are, you've missed it by a little bit. You've missed it by just a little bit. Sanugushe, what's up?
Hi, ma'am.
Hello, my sweetie.
Ma'am, may you please repeat the entire sum? I do not understand.
Okay. Cool. All right, don't go away. I want to have this conversation with you. All right. Do you agree with me that inside x squared there is x, right? Because x squared is the same as x times x, right?
Yes, ma'am.
X squared is the same as x times x. So if we have to choose an LCD, I can't choose x because it's smaller than x squared. It's not going to work. But I know that inside x squared, there's an x, correct?
Yes, ma'am.
So my LCD is x squared. Are you with me here?
Yes, ma'am.
Okay, excellent. So I know that my LCD is x squared, so I'm going to put everything over x squared. Right, and then we do the same thing we would with any other fraction. I've got a denominator of x over here, Zanogushe. How do I get from x to x squared? What do I multiply by?
By x.
Good. And what I do at the bottom,
I do at the top.
I do at the top. So I have to multiply by x at the top as well. Now, on this one over here, I've got x squared on this denominator. What did I do to get from x squared to x squared? What did I multiply by?
Times 1.
Times 1. And what I do on the bottom?
I do at the top.
We do at the top as well. Then we can just do this. We just do it the normal way. What is x times 1?
X.
X.
Oh,
Good.
1x.
And then I've
Yeah, x.
or 1x or just x. Right. And then I've got negative 4 times 1, which is
Negative 4 times 1 is negative. Yes, negative, ma'am. Negative 4.
negative 4. And that's the answer I've got. Is there anything common at the top or at the bottom that we can cancel?
No, ma'am.
C. And that's how we got to the answer. This is the answer that we're looking for. Does this make sense a little bit more?
Yes, ma'am.
Excellent. Okay. Remember, we're always looking for the lowest common denominator. All right.
Thank
Well
you,
done,
ma'am.
Senator. You're very welcome. All right. For those of you who said that you want to make x cubed the LCD, let's do that and we'll see what happens. If I make my LCD x cubed, and after this, we're going to have a brain break. If I make my LCD x cubed, I'm going to have, how did I get from x to x cubed? I multiplied by x squared. So I'm going to multiply by x squared at the top as well. So I'm going to have x squared. And how did I get from x squared to x cubed? I multiply by x. So I'm going to have x over here. So I'm going to get x squared minus 4x. And then I'm going to notice that at my top over here, I've got an HCF. I've got an HCF over here. This top part has an HCF of x. So I'm going to take x out and I'm going to have x minus 4 left over x cubed. And then one of these x's is going to cancel out with one of those and I'll have 2 left. And that takes me back to my original answer. Willenda says, how did we get x minus 4? Okay, it's because we multiplied the top, Willenda. Whatever we multiply the bottom with, we also need to multiply the top with. Okay. All right, if you're still a little confused, wait until we put this up, until we put the posting of this lesson up and go rewatch this part. The best part about the video is that you can pause and rewind and do it slowly and listen to the explanation again and again, and it'll make a little bit more sense. Okay, Willenda? Kayla, I'm loving that. You should tell your school to hire me. Nah. As long as you guys don't have load shedding, I'll be there. Okay. Excellent, guys. All right, let's have a brain break. All right, now this is a magic square. For those of you who were with us on Thursday, you remember what magic squares are. Magic squares are when we have to add up numbers all around for them to give us the same number everywhere. I'm going to tell you guys now that I need 45 on each of these sides. I need 45 on each of these sides. So let me know. Alicia's like, finally, after 2 years. I'm sorry, guys. All right. Tell me, I need 45 on all sides. Start putting things together, guys. Tell me where what goes. Okay, Coco says 9, 15, and 21. Okay, we've got 21 over here. Apiwe, what do you think? I know. Can't believe she would do such a thing. Okay, Courtney says 12, 9, and 24. So I'm assuming down here we've got 24. Keep going, guys. Bring those answers. And Akwande says 27, 15, and 3. Excellent. Keep going, guys. Okay, Untatile, I'm going to explain what's happening. All right, so everybody is adding up all these numbers so that they give you 45 when you add them up in every way. So all of these numbers in this direction, 12 plus 9 plus 24 needs to give you 45. These numbers together needs to give you 45. These numbers together need to give you 45. Those numbers together needs to give you 45. Those numbers added together must give you 45. Those numbers added together must give you 45. Also, those numbers added together must also give you 45. So we want 45 all the way around. Okay, and that's where people are getting these weird numbers. They're adding numbers together to get 45. And Michael, we cannot multiply. We must only add. Okay, now Abigail says 1227 plus 6. I've seen other people give me this answer as well. Okay, that's excellent. And you can only use one answer once. You can each use one answer only once. And then Amy says 24, 3, and 8. I'm not sure about that answer. 18, that makes a little bit more sense. Now, I want to ask you guys something. On Thursday, if you were here on Thursday, guys, we did a magic square with 15 in it. It was 15, right? And in that magic square with 15 in it, we only use the numbers from 1 to 9, right? Today's magic square is 45. We're adding everything to 45. What do we notice about all the numbers inside the magic square? What do we notice about all the numbers inside the magic square? Who can tell me? What's interesting about all these numbers in the magic square? 6 above 21, not really. They're not prime. Okay, under 30, not quite. Kayla, you guys are magical. That's it. They are all divisible by 3. This particular magic square is 45 and 45 and 45. And 45 divided by 3 is going to give us 15. And all the numbers in here are divisible by 3. Watch what's going to happen, guys, when I divide all the numbers by 3. This is going to be 4, 3, 6, 1, 5, 9, 2, 7, 6. Ooh, I lied about this one. This one is not 6. This is 8. Why am I lying like this? 8. Do you guys notice that we've only used each number once? You guys notice that? We've only used one multiple of 1. 1 times 3 once, 2 times 3 once, 3 times 3 once, 4 times 3 once, just like we did with the other magic square. They add up to 15. Look at it. 4 plus 9 is 13 plus 2 is 15. Excellent. Now, interesting, isn't it, Inganati? Right. It's not the square root, Dorothy. It's just multiples of 3. Now, I want everybody to take a screenshot of this one. Okay, take a screenshot. We're not going to do it today. I want you guys to go have a look at all the numbers inside the magic square. And I'm not going to tell you what they add up to. I want you guys to come tell me on Wednesday what it adds up to. Okay. And just remember, guys, that everything in there is going to be some multiple that adds up to 15. Akwanda, you're ruining it. Akwanda, stop. Stop. Okay, let's continue. All right, let's continue. Akwanda is totally ruining it. It's not that tricky, Nganati. It's like he just ruined it for me. It was like YKTV. I don't know what that is. Shangile, what's up, my sweetie? Oh, Keoratile and Akwande are just ruining the game for me now. Shangile, what's up? Okay, Shangile is not unmuting, guys. So we're going to continue quickly. All right. So I'm subtracting 2 fractions, guys. So I'm going to need to find an LCD. What is my LCD going to be here? What is my LCD going to be, guys? I'm so sorry, Kayla. That's all good. Let me know, guys. What is my LCD going to be? It is tricky. Now think about it. It's not going to be -4, Melissa. Think again. Remember, guys, Tatum says it's 2x, okay? And we're going to test that theory. If my denominator is 2x, right? Mirula says 3x minus 2. Dorothy says 4. Okay, let's test this out. Buntu says 4x squared. All right, let's start with 2x. Let's think about 2x, guys. If I decide that my x is equal to 2, what I'm going to get at the bottom here is I'm going to get 5 over 2 times 2, which is 4, minus the top doesn't even matter at this point. X plus 1, we're only looking at the bottom. And then I'm going to get x minus 2, and I'm going to get 0. That's not going to help me. This thing is undefined. Okay. So let's maybe make x equal to 3. And I'm going to get x plus 1 over 3 minus 2, which is 1. Okay. Is my LCD still 2x? No, it's not, because the two numbers don't actually go into each other. If I make x equal to 5, I'm going to get 2 times x, which is 10. And then over here, I'm going to get 5 minus 2, which is 3. Is my LCD, do my LCDs go into each other, 10 and 3? They don't go into each other. Okay, remember, guys, they don't go into each other. Apiwe says, I'm confused, ma'am. I'm going to explain now. Remember, guys, when we said, if I have 1 over 2 plus 1 over 3, are these two numbers the same? Are 2 and 3 the same? Are they the same number? No, they're not the same number. Okay, they're not the same number. So how did we find the LCD here? Well, how did we find the LCD for these two numbers? What did we do, guys? That's it, Inganati. What did we do, guys? We multiplied this one and that one, and we got 6. That was our LCD. And the reason we did that is because our LCDs were different. They were both different, right? They're different. Look at these two LCDs. Are these two LCDs the same? Are they the same, guys? Nope, no, they're not. I can see Muriel going, no, they're not. They're not the same. So how are we going to find the LCD, guys? How are we going to find the LCD? Inganati, you're literally on fire today. We're going to multiply. We're going to take them together and multiply them because they don't have anything in common. They don't have anything in common. So I'm going to go 2x multiplied by x minus 2 because they're not the same thing. They're not the same thing. So I can't now look for things that don't exist together. My LCD is going to be the two things multiplied together because they don't have anything in common. Now we just need to look at the whole LCD. Look at the whole LCD. This is my whole LCD. And over here, I only have 2x of my LCD. What is missing over here from my LCD? That's it, Kayla, that is it. If they're not the same, we multiply. All right, if they have nothing in common, we multiply. What is missing from this LCD over here, guys? I've only got 2x. What's missing from my LCD? Tell me in the chat. What's missing? That's it, Patu. Hello, Patu. I haven't heard from you all day. There we go. I know that x minus 2 is missing. So I'm going to have to multiply this part by x minus 2. And what's missing at the bottom? I mean, what I do at the bottom, I must do at the top. So I'm going to multiply the top by x minus 2. Right. Let's look at this side. Over here, I only have x minus 2 of my LCD. What is missing? Thank you, Michael. Michael had that, you had that typed in and you just put it in there. So I need to multiply this side by 2x, which means I need to multiply my top by 2x. Okay, don't forget the negative. The negative always comes along. Don't forget the negative. So what I'm going to get in the end is at the top here, I'm going to have x minus 2 multiplied by that 5 that we already had, and then minus 2x multiplied by x plus 1. And then what can I do? Yes, Patu.
Afternoon, ma'am.
Hello, my sweetie. How are you doing?
I'm good. How are you, ma'am?
I'm good, thank you. What's up?
Ma'am, I wanted to ask, would it be wrong if we were to distribute our 2x at the bottom before like doing the top and the bottom thing?
No, not at all. You're not. But remember, when we are looking at all of these, it's going to be a lot harder for me. Imagine, let's say, for instance, part 2, my LCD was x minus 1 times x minus 3 times x plus 2. Now, if I multiply out, right? If I multiply out, I'm going to get x squared minus 4x plus 3, and all of that multiplied by x plus 2, and then all of that. How am I going to see what's missing on the top?
Oh,
It's going to be very messy, and I won't be able to see what I'm missing. Do you understand what I mean?
yes, ma'am.
Okay, so it's a lot easier for us to keep it multiplied just like this, so that I can see exactly what I'm missing at the top. You understand what I mean?
Yes, ma'am.
Excellent. Excellent.
ma'am.
Well done. Nice question. That's a very good question, by the way. All right. So I get to distribute, guys. Don't forget we need to distribute in. Okay. So I'm going to get everything over 2x and x minus 2. So at the bottom, I've got 2x into x minus 2. So 5 times x will give me 5x. 5 times negative 2. Yes, you can, Melissa, because multiplication, it doesn't matter which one comes first. 2 times 3, 6. 3 times 2, 6. It doesn't matter which one we multiply first. And then I'm going to get negative 2 times 5, that's negative 10. And then I'm going to distribute that negative 2x inwards, right? I'm going to get negative 2x times x is minus 2x squared. And then negative 2x times 1 is negative 2x. All right, now we can add like terms, guys. We can have a look at adding like terms. Then I've got negative 2x squared plus 3x minus 10. And then I can't see your name. I think it's Miso. Miso, can't they just cancel each other out? No, they don't. And the reason they don't, Miso, is because there's a minus in between them over here. They don't cancel out. Okay, the only time we can cancel is if we take out x minus 2 as a common factor. Okay, they don't cancel out. All right. Yes, Sanuguche.
Ma'am, I was just gonna ask where the 3x comes from, but I see it now, ma'am.
You see it. It's this 5x minus 2x. And that gives me
Yes, ma'am.
positive 3x. Samuel, do you see it as well? Because Samuel was also asking the same question. Okay, I just did some very quick multiplication. Amy says, can we multiply the denominator? Yes, Amy, you can, but it's going to make it so hard for you to see what is missing in each of my denominators. Okay, let me explain to you guys. I'm going to do this question again. Let's start this from the beginning. Okay, let's start this from the beginning. And I'll show you guys why you shouldn't multiply out the denominator. Okay. Just give me a thumbs up. Do we all agree that my LCD is 2x multiplied by x minus 2? Give me a thumbs up in the chat if you agree with me. Because they don't have anything in common, I multiply them. Yes? They don't have anything in common. 2x and x minus 2, not the same thing. Not the same thing. Okay, excellent. That is our LCD. 2x and x minus 2. Right. Now, let's say now that I want to take this denominator that you guys have given me and I multiply it out. If I multiply it out, let's distribute, guys. 2x, x minus 2. So I'm going to get 2x times x is going to give me 2x squared. And then 2x minus 2 is going to give me minus 4. Right. If we do that, guys, look at my denominator. This is my denominator. Now I need to see from here, from this 2x, okay, I need to see from this 2x what is missing. I'm going to close up this denominator quickly. I'm going to close this one up. We don't see this one because we're not using that one. Now, remember, my denominators need to look the same. If I look at this denominator, what is missing from here? What is missing? What do I multiply the bottom and the top by? It won't be negative 4x. Do you know why, guys? Do you know why it's not 4x? This is why it's not 4x, because if I multiply this side by 4x, let's multiply out. 4x times 2x gives me 8x squared. That looks nothing like my denominator. It looks nothing like my denominator. Okay, and it complicates things because I don't see it. Okay, however, if I leave, yeah, and now I'm canceling everything, 4x. If I leave my denominator looking like this, if I leave my denominator looking like this, have a look over here, guys. Have a look over here. I've got this denominator, and over here, I've got this one. What's missing from there to get to from here to there? What's missing in between the two of them? What's missing, Mulisa?
X minus 2.
Thank you, x minus 2. Where did you see that? Where did you see that x minus 2 is missing?
Because not sure how to explain it, but
It's because, okay, if this is my denominator, right? My
Yeah,
denominator. I already know that I have the 2x part. What's missing in my denominator up top is the
X minus
x
2.
minus 2, right? But if I multiply out, can you see it from here? Can you see that x minus 2 is missing from over there?
Yes. I think yeah, you can.
Can you see it really? If I cover up this one,
Hmm?
will you be able to see from here what is missing in my
No.
denominator? No, you can't see it. You can't see that it's x minus 2. Okay, so guys, if you multiply out your denominator, it's going to get complicated. Okay, for those of you who are confused, let's just keep to this rule. We do not, because it's going to get complicated. Do not multiply out. Let's just keep to the rule. Do not multiply out the denominator. Okay. Don't do it.
If you have variables in your denominators.
If you have x's and 2's, like, and x squareds, do not multiply out the LCD. Okay. I'm going to ask you guys again, what did I just say about the LCD? Tell me in the chat. What did I say about the LCD? I know it's confusing, Winnie, because people want to multiply out. Do not multiply out the LCD. Do not do it. Okay, don't do it. Just take the two numbers and multiply them together. Okay. Do not multiply out the LCD. It's going to complicate life. You will not see what is missing from the top. Okay. Thank you, Q. Thank you, Jerison. That's it. Thank you, Nsako. Thank you, Mulisa. Thank you, Busiwe. Thank you, Lusanda. Do not multiply out the LCD. Thank you. Thank you, Teacher Neliswa. If you have more than one term and there's X's and Y's involved, do not multiply out the LCD. Akwande, how do we know when we don't multiply? Always, just don't do it. Just don't do it. If my LCD, let's say for instance, my sum is 2 over x plus 1 plus 3 over x minus 4. My LCD is just going to be x plus 1 and x minus 4. Do not multiply out. Don't do it. Just leave your LCD like this. Take this one and multiply them together, and that's your LCD.